Hello folks, well today we've got a DNT B40, which is the base station. It's very similar to an M40 with a power supply bolted on the back, but all the component values are different because the power supply is 12 volts, it's not 13.8, so for this radio to have a fighting chance of doing anything near 4 watts on 12 volts, the component values have to be different, so not interchangeable in that respect. I think we usually get somewhere like 3.6 to 4 watts out of them. They're problematic and have been problematic from day one because they're unreliable owing to dry joints. They have a cheap SRBP printed circuit board and it's plated through just relying on component leads soldered both sides. Customers had a go at this and I don't think he's got anywhere with the power supply, but we're going to do the set first on 12 volts, and don't lose these screws because they're I think they're M2.5 by 4mm. So we will open it up. I think he's done some other recapping, but what we'll do is look through the radio, do the servicing on that, if it's doable. Don't go rushing out buying one of these. They're not reliable even when they're done, and that's embarrassing. Right, so that's all the lids off. Yeah, speaker's not soldered back, so that's fine. See, he's done that one. The receivers on these are crystal filtered, unlike the ordinary version. Of course, there was the super tuned version, which was reworked by Cleartone in the UK. That could be new as well. Anyway, what we'll do is we'll power it up from 12 volts and ignore the power supply. There's nothing in there that can't be replaced. So, you know, that doesn't worry me at all. Sometimes we uprate this to be, I think this is a regulator chip there. It's 7812 CV. I'll have to look that up. I think it's 1.5 amps, and I think we've upgraded it to a 2 amp one. But I'll have to have a look at the diagrams to see if he's made a mistake anywhere and sort that out. But so we'll worry about that later on. Got the power supply disconnected, as I can see, and the speaker, or does that go to the speaker? No, yeah, that goes to extension speaker. Yeah. So, the difficulty with these is you need 2 signal generators to do the tuning, because you've got to set 10.24 with this crystal, then you've got receive and you've got transmit to do separately. So it's a bit of a time consuming kind of set. Right, we'll get it connected up to 12 volts. Power supply on 12 volts. So all we should need to do is to put one end to chassis and one end to the volume control switch. Just like that, and we're lit up and we're on channel 24. So we'll change that to 20. Get the test gear plugged in, do not apply 13.8 volts to one of these, or it will be dead. Factory original mic, always nice to see that. And we'll need to run on the extension speaker, and first of all we'll use the one on the wall to make sure we're not putting volts up the test gear. So we've got an FM hiss, the kind you'd expect. Let's switch picture in picture on, and let's see if it's doing any transmitting. It is 2.4 watts, I think that's it. I'll just put the squelch on. In fact, I think we'll just put the signal generator onto the right frequency, because we've been running on, we're doing CPT last, 2779125. It's receiving fine. Well, it's 100 microvolts. Yeah, it's receiving sensitivity you'd expect. So it's clearly dealt with any dry joints. It's just going to be a retune and sort the power supply out. I'm just scared I might have to order parts for that. Right, I will go and get, I'll tell you what, I don't think I've seen a plug like this before either, bearing in mind we're in the UK. Standard, mind you, is that a 3 amp fuse or a 13 amp fuse? It's got a switch on it. So, I mean, most outlets in the UK have switches on them, but not all. So that's really handy. I remember Woolworths selling plugs like this with a neon and a switch before the shrouded pins came in, and of course Woolworths is long gone. Right, I'm hoping the in tray is behind me. It is, and we've got a sheet, September 25, DNT B40. So we'll just fill in a few things. Let's go back to the main meter. Test equipment has been on for about an hour. I'm going to put the test set on behind me so we can do deviation. That'll take 20 minutes to come on. Right. So we're in high power and we're on the 3 watt scale. It is 2.4 watts. Channel 40, 2.2 watts. Channel 1, what's it going to be, 2.6? It is 2.7. That's slightly out of balance. I'm sure we'll be able to improve that. Back to channel 20. It's 1.196 amps, which is a lot for the power output, so I think something's off tune. On low power, it's doing 210 milliwatts. Deviation on this test set, wallow, 1 2 1 2. Got to retune it, 1 2, wallow. I've got no audio. I've got no walkie-talkie on here either. Let's try that again in the right setting. Wallow, still got no audio. 1 2 1 2, wallow, 1 2, wallow, 1 2. Got no audio. I'll have to get my walkie-talkie back. So that's still up in the air. Frequency. Go back to camera 2. 27.79145 is slightly high. 79145. We've got to do 10.24 before we fiddle with those. Receive. So we'll plug our test gear in now to the extension speaker socket. And we'll put that on the oscilloscope. Now normally I would set the signal generator to how the receiver frequency is, but we don't know what the receiver frequency is because I need to put a second signal generator on. What shall we do? We'll go to camera 4. What does that say? We've got all I can do is put very low. It's reading S1 regardless of the signal. We'll just look at the S meter though on and that's reading low. We're on low power though, aren't we? That's reading about where you'd expect it to be. It's okay for the power it's putting out. We've got this running through the power supply somehow. It's going backwards through the power supply. That's why it's drawing more current. I can't say I've seen that happen before. I'm going to have to look at the circuit diagram to see how that's done. Pause the video while I print off a lot of pages. Okay, so I've got the circuit diagrams here, and I think he's got one of the capacitors in the wrong way around in the power supply. So what we're going to do is to disable it from running back into the power supply. So T1 is the choke. So you've got the power supply here. So if we're powering it up at the on and off switch and the power's running backwards, which of course it will, it shouldn't go any further than the IC. It shouldn't do anything. So I think he's got capacitor 203 in backwards because something's getting hot. So, hasn't blown up yet. If we disable the input from the power supply, so it can't run backwards into the power supply, so we need to find where choke 1 is and disconnect it. Well, obviously it's there. So when we look at this layout, the positive goes to there. So we've got that pink wire. Well, that's a novel thing because the pink wire goes to extension speaker, And the black wire that's not there is the power supply one. The black wire that's not there is the power supply one. I'm just going to make sure we've got the power supply off. There's always something, isn't there, folks? Well, I can see a bulge on this capacitor, the bigger one. What I didn't want to do is to do the power supply at this stage. So how's that getting powered if the wire that normally goes to there is disconnected? Because I think the pink wire so we should have extension speaker. I don't know. It looks like the pink wire is what the black wire should be. Just going to desolder that hole properly so I know where it's come from. So that has now made the input side open circuit. That's the idea. So that's our power supply input. So now we can carry on without things going funny. Right, power back on. So we're lit up again. We're now drawing less current at 189 milliamps. And when we go into transmitter, we're drawing less current. 1.16 instead of 1.19. So we've lost 300 milliamps. Right, so I think we've got away with the problem. I think the alignment's pretty good on this, but we've still got to go through everything. So I've printed off. The other guide we've got is this Doncaster produced, turning it into a 10-metre piece of junk. Oh, my printer's set up to do it the other way on. How frustrating. But the point is that we've got the layout. This is very useful because so many of these got modified. We've got the layout for what the things are in here, so it saves me faffing about. Oh, there is a low power preset. So we're on channel 20. I'll do the transmitter, and then we can set the frequency with the 3 crystals which we need to do. And it would be nice to get a bit more power. In fact, we've come straight up to 4 watts now that my power isn't being robbed. So there you go. That's the difference. I still need to go through the alignment because it's a bit lopsided. So it's 16, 17, I think it's 17, 16, 15. So 17. $16 is sealed, but we need to unseal that to make sure it's right. Yep, happy with that. 15. And if any of these are broken, changing the coils, trust me to say that when this one looks like it's broken, changing the coils is a no-no. They're so difficult to unsolder because of the double-sided boards. And I don't know whether I jinxed that, but that is a broken one. So I mean, I can't do anything about that. If we're on a desert island, we've got all the time in the world, then perhaps. Now that I've been able to peak. Then we'll move on to these. To be honest, this is quite centralised. But is that wax or is it somebody's put? I didn't know whether it was kind of bathroom sealer or something in there. But I think it's candle wax. Right. There is one in that, but that is the one you do with the spectrum analyzer if there is one in there. So we've got 4 watts on channel 20, so I'll just do the other channels. Channel 40, yeah, 3.5 watts. Channel 1, 4.1 watts. So it may be possible that this is the one which needs to be tuned the opposite way. So that gives us 3.95 watts on channel 40. What does it give us on channel 1? It gives us 4. That's it then. So it had to be down for 4 watts and not up for 4 watts. Done it. I'll just tidy that coil back up. So when it's back on its own power supply, it's going to be slightly different, but at least we know it's capable of 4 watts. So we've got 4 watts, 4 watts, 3.95 watts. That's a good outcome. Now he's changed the capacitor here, and I'm just checking. It should be positive to. I mean, surely it would be getting red hot if it was wrong. Positive to this side, so the negative stripe is to the back. That might have been changed. That's the wrong way around. What about this? I mean, that looks like it could have been changed. That's correct. Show you. So something's dry joint just there. So we've got capacitor 53, which is that one. Negative to the, sorry, positive is the stripy side on this one. C57, and it should be positive to the left. and it's showing, the capacitor showing is negative to the left. Now 57 I think is in the amplifier. '53, '56. '57. So negative should be towards the output, positive towards pin 4 of the IC. It's the wrong way around. Right, I'll turn the power supply off, we'll deal with that. The fact it's the output coupling capacitor may be the reason it sounds a bit funny. Hope we don't rip half the print out with it. A very brave man tackling one of these at all. I think of some modern sets which would be much less forgiving if you got something wrong. So that's come out negative to the left, and the diagram clearly shows positive to the left. Back at the diagram, we've got 220 microfarads, and it should be 220 microfarads, so that's correct. So we'll get a new one of those. Not going to put that back in. I'm not trying to sell the bloke parts, but you once have been reversed. We'll be using very high quality Nikon ones. Nothing wrong with the quality he's put in either. Right, 220 microfarads. Negative is the stripe. So I've got positive to the left. Once again, definitely positive to the left. I'm holding it with one finger. At the end of this I'll go over it with isopropyl alcohol as well. I'm just thinking there's possibly something dry jointy. Power back on. Doesn't sound any different. I think we may as well do deviation on the test set behind. Oh, we hadn't got any audio, had we? That's right. Let's go back to that. Wallow, no audio. I need to fetch the walkie-talkie, which is what I put it in another room to charge, and then I've forgotten to charge it and forgotten to bring it back. Okay, so we're on channel 20. We've got a flat battery on the walkie-talkie, but testing 1 2, testing 1 2 1 2. There's nothing, is there? So let's see where the fault is. I mean, it could be a duff mic, couldn't it? So I'm going to stick my finger on the appropriate pin. Does it show the mic unit on here? It doesn't, but pin 1 is clearly the transmitted audio. So I'll go to low power so I'm not heating up the radio. And here we've got transmitted audio there. One two 1 2. But we haven't got it coming through the mic. So I'll tell you what we'll do. We'll get a standard test mic out instead of using the customers. I think we've got one. T on it. Testing 1 2, testing 1 2, 1 2 1 2, testing 1 2 3 4 5. So it's quite low audio. Wallow, wallow. It's 1.5 on that test set. I'm just going to see. I'm going to have to upset this because I want to. It's a bit of a faff using one behind, but I just want to make sure we're heading in the right direction. So deviation preset. Go back to that here. Low power. Transmit, receive, VCO, FM, and DEV is that one. Wallow, 1 2 1 2. Now if we can't get the right volume, there's a fault, isn't there? So I'll go over to the test set now and see where that is. If this test set's working right, we're looking at 1.5 deviation, which isn't adequate. Wow, it just is hitting 2 at maximum, so there is a fault. So speech processor well, you've got capacitor 81 could drag it down, capacitor 79 could drag it down, capacitor 78 is a coupling capacitor, which could definitely be the thing. Capacitor 80 is a coupling capacitor, so I think we should go for those 78 and 80 as priority. 78 and 80, we'll change them both. They're both 1 microfarad. So where are they? I'm probably going to put my walkie-talkie on charge for what it's worth. 78 and 80, yeah. So 78 is there. It's the wrong way round. It's been changed and it's the wrong way round. Well, in that case, we'll just change that one. Got to find it though. I think it's those two. Negative to the bottom, capacitor 77. It just looked like it's been changed, and probably has been changed and correctly changed. But we're changing it again. I'll just do that as a potential dry joint there. And we'll go about doing this. Is going to be a long video. And it has to be done today, otherwise it'll be a part 1. So we're back to ones which it should have been. I should have been looking at 78 and 80, wasn't it? So 78. So we've done 77. '78 is the right hand one of these two. And so these are both the right way around. We're going to change them because they are coupling the audio. Trying to find them. I'm going to do this off video because it's going to be forever. Right, folks, I've done some more capacitors as the other two, which are 2.2 and 2.2, which were the decoupling ones. So I'll put some charge in this, but not a lot. Let's see what it sounds like. Testing 1 2, testing 1 2. We're getting feedback now. That's great. That's fixed that then. So I'll just do the deviation. There we are, that's set up. Now of course, the whole start to this was we'd got no transmitted audio. So I got my standard test mic out. So the next question is, does the mic actually work that's come with it? Let's go over to the main meter. Turn the squelch up. So we'll plug in the original mic, put the walkie-talkie back on. Testing 1 2, testing 1 2. No, that mic's dead. So we've still got a fault on the mic. Go back to our mic. Testing 1 2, testing 1 2 3 4 5. Good. So when I did the first two capacitors, we got the deviation from about 1.8, was it? Let's look at the clipboard. I didn't write it down. I'm going to put down 1.8. So we've changed 220, we've changed 100. That wasn't necessary, but it might have been. You know, you can't tell. It was the it's this capacitor. Where's the speech processor? So this capacitor there, which is the smoothing capacitor for the power supply for this speech processor's voltage rail of 9.1 volts. So that's what I changed without intending to, but it's you know, for the cost of those, well, they're 28 pence or something, you know, it's worth doing. So then we've got those two which couple the audio stages. Changing those brought my deviation up to 2.2, and although that's acceptable, I know these sets are capable of more than that and usually need to be turned down quite away from maximum, of course. And so I've changed 81 and 79, the two 2.2 microfarads capacitors there, and that's brought back normal operation. So that's now 2. So we've done 2 times 2.2, 2 times 1. So mic deviation, it was faulty at 1.8 kilohertz. Supplied mic not working, no audio. Right, so we'll carry on with the two. I'll just see whether we've still got 4 watts. I'm on low power, of course. Yeah, we've still got 4 watts. And we want to do the low power adjustment. So we'll switch to low power, and we've still got about 140, no, it's 180 milliwatts. So which one is low power? Might as well use this one. It's the preset just there. Changes glasses. That's 400 milliwatts. So that's another done. Right, 400 milliwatts. Let's look at the current consumption now on full power, and it's 1.163. 1.163. So it's come down to do a watt and a half more. Now 300 milliamps of that was the power supply dragging on it. So there we go. So that's the transmitter done. We've got all the frequencies to set up, and I think we'd better do that next. Now, can I manage to hold all this on? I think we'll do it the easy way. I've got probes elsewhere, but not in here. So it doesn't alter the result, it just makes it a bit crappy technique wise. I'll solder my earth to this can. Knowing that's earth. And this one's had probes on it and it hasn't now, as you can see. I've got to look up what pin it is we test the 10.24 at. If we go over to the frequency counter, if you don't get this right, your receive's going to be lopsided, because the 10.695 and the 455 IF are going to be out, and with it being crystal filter, be quite important it isn't out. So 10.24 is the one there, and we can pick that up where? I did have diagrams for these, but I've thrown them away because I'm never going to see one again. And then we get another. So where am I looking? Phase lock loop chip. It's between pin 3 and pin 4. So I would think we test it at pin 4. One, 2, 3, 4. So over to the frequency counter. Let's see whether we can pick it up on this one. Yes, we can. Well, that'd been fiddled, hadn't it? .24. I'll leave that in place. And then one of these is transmit and one of these is receive, but I can't tell which. It's the one on the right is transmit. So we'll do that next. Again, I may as well put the radio on low power and not generate the heat. Switch that back to internal. 27,79105. So it's now, we've got to hope we can get that down. Sometimes you have to play compromises if the crystals have drifted. So we've got 10.24, so we want 27,79125. Yeah, that's going. Even if we left it here, it'd be fine. There we go. It's just slightly high, 27,79127. Now we've got to do the receiver. So we need to put the signal generator on 27,79125. And we want that exact. There we go, 27,791. And then we need to get the marker oscillator, which is a secondary signal generator. I'll unplug the printer, then it'll come up with a message. I hate you, you didn't switch me off properly. Signed, Hewlett Packard. Right, so we need the signal generator, so we can hear it. And I've now turned the tone off the signal generator. We've got the carrier, and I've got it to 10 microvolts. Switch this on, and we want 10.695 out of this. All we have to do, you know what, it sounds spot on. Good grief, that was hardly out at all. Well, there you go. What is the... I mean, 10.24 was miles out. Transmit was a lot out. And receive was nearly spot on. And there's me wondering if we're going to be able to actually get it to go spot on, or whether we've got to do a compromise. We haven't. It's spot on. Tone back on. It doesn't sound right, but I'm assuming we've just got the receiver to do, and that's why. So we'll start by doing the detector. And put the oscilloscope on, which I haven't put on yet. So remember, if you get a DNT or the JWR and that ICOM 105, and remember ICOM, the CB ICOM, is nothing to do with the communications company ICOM. It's a made-up name. They all use this triple crystal mixer, so did some of the team sets. It's not a very nice waveform, but there you go. That's a better waveform. That's better. But is it good enough? We've got 3 to do in the receive. 1, 2, 3. So we'll do those next. Do that with the cyanide meter. Just a little tiny bit on that one. I'm going to go back to this one. Wow, miles out. So now I'll double check with this one. And I'll finally go back to the detector. It's got a kink in it. Might have to manoeuvre. Well, it was certainly screwed up, wasn't it? Now, before we take any readings, checking the RF gain there, I just want to see if the meter actually will read, because you remember it was only reading S1 with a whacking great big signal. Yes. Meter's actually sticking just beyond 9, but that's obviously the way it is. I'm not going to start dismantling meters. So we've calibrated that. Just check we've got the transmit meter calibrated. Oh, it doesn't stick there. I was lying. Should be in the centre of the red zone, which it is. And I've just lost my earth. I think that's it. I think we're done as far as the radio goes. So we'll get some new readings. Oh, we're going to have the squelch to do, aren't we? Tell you what, let's see if we can do that now. So, squelch to full. I'm not sure we can get what we'd normally like. It's not adjustable, is it, on these? No, you get what you're given on the squelch. Maximum squelch is 6 microvolts. And minimum show the attenuator. I parked it at 0.3 of a microvolt. Signal generator back on. Straight in at 0.3. second time round it didn't come in at 0.3. 4.2. 0.42 microvolts. So we've now got 2.2 to 2.5, 27,79125. That's now correct. That's now correct. Meter lamp works, doesn't have PA. Sockets, potentiometers and switches work. We didn't take a receive figure beforehand, but it was so nasty, as you can tell by those waveforms. The sensitivity was there. I could still hear it at 1 microvolt, but it would have been pretty garbled. So let's see what we've got now. So for 12 dB we've got 1 microvolt. I could put 0.99. We could also see whether we can just get a fraction more, but I doubt it. No, absolutely optimum. It's 1 microvolt. .86. So it's about on a par where most unidens are. I once did a York 861 for this gentleman, and it was one of those which was off the clock at, it was less than 0.2, you know, like 0.197 or something, which is one of those sets in 1,000. So I certainly noticed the difference between that and this. 20 dB, 3 microvolts. I'll be naughty and just touch that. Actually, depends whether we've got a garbled waveform. You know, that I'll go back to the I mean, that's not the best waveform in the world, but I think we've just gained a fraction on the sensitivity. Let's look at those again. Yeah, we're better off with a slightly kinky detector. So we've now got 0.68. .52. And our 20 dB 2.8. Right. Just make sure my meter's still where it should be for S9. It's now slightly over. And if we go into if we put the local switch in, you'll see, well, it does make a difference. I mean, the high-low power, what a twit. That's it. Right, so the radio's finished. We need to do the power supply. We'll turn some of the test gear off because we're done. So basically all that's wrong is he's got a capacitor in the wrong way round, so it will need to be replaced. But they're quite difficult to get to. So we need to get this screw out. And we need to get that screw out. And we need to take the regulator off the heatsink. I think there's a nut and bolt on that. Maybe wrong. Easier to get it out of the bottom. Right, there we go. You can see it's now got a bulge in it because it's knackered. So, let's go back to our circuit. So we've got the two the same way on now. Capacitor 203. Yeah, is the one which was being affected when 203 is here. So there's our on and off switch, there's the choke, there's 203. 2200 microfarads. We need to pop that out and put a new one in and get it the right way round. So when you look at the diagram, it says negative to the left and positive to the right, which is how he's got it. But the other one, that's bizarre. Oh, hang on, I've got this topsy-turvy, haven't I? It's shown upside down. That's the problem, it's shown upside down. So that was the right way round. Yeah. Right, we don't need to know that that's knackered. So here's a bit of a tip. This part of the printed circuit board, where it's got the most copper, is the ground plane, and it's at negative. You see, we've got the screw to chassis there, so we know it's at negative. So most of the time, not all the time, especially, but on things which are relatively modern, and this is relatively modern, it's 40 years old, I know, but I'm thinking about if you were looking at PMP transistors with germanium in transistor radios of the 60s, it would be different, so don't take notice of what I say. But in this case, this is the negative. And so we can see we've got the negative on that capacitor to the ground plane, and you can see on the diagram it's negative, and the other one is negative to the ground plane. Of course, it was the wrong way around. So I'll go and get one of those capacitors. Hopefully this one's a bit more squat. So it's negative. Now, of course, until we power this up, we don't know that the bridge rectifier is any good. We'll get some isopropyl alcohol on that. I'm going to power this up in free air. It's not, remember, it's not connected to the radio anymore. And the other thing to bear in mind is whenever these are plugged in, I'll turn that off. Whenever these are plugged in, the power supply is running. The on and off switch is just the low voltage. It's just the 12 volts out of the power supply. So that is in free air. I'll just make sure that paperwork's on there so it doesn't go to earth. Because we're not drawing any current, there's not going to be any heat generated, and I'm going to plug it in and we'll see whether it actually does anything. It's now 6:30. I'm going to have to go. I'll try and come back and finish this. Got 7 volts across that. Six volts across that. So we should have, what, 15, 16 volts on the AC input. Why am I only getting 10 volts across it? Let's look at the DC coming out. 9 volts coming out. That's not right. That ain't right. I'm going to disconnect the bridge rectifier. I just think, you know, if you put a massive short, which you effectively half by ending up with the capacitor in the wrong way around, you know, it's only something like a 2 amp bridge rectifier, so it's easily damaged. What I'm going to do, I'm going to end up breaking the print. I'm going to cut this out. We'll put a new one in anyway, but I want to test. It's so close to the board. So the plan now is power it back up, and we should only have AC. There we are, back on, and we should have no more than 9 volts. There you go, 16.6 volts. That's what we should have. So the bridge rectifier, which I've cut out, is knackered. So I'll come back to this hopefully today. Right, what we're going to do, if I come to the conclusion of taking across that bridge rectifier out, we're going to change the regulator IC, uprate it. I think the 1.5 amps, we'll change that to 2, because there is a stronger version. They're not expensive, again, they're less than £1. So that's the thing to do. I'm going to have to order both those parts. So what we're going to do is we'll bring this to a conclusion as part 1. I'll just plug the test gear back in. I'll tell you what, I'll plug the aerial in. We'll see if Mr. Chippie is lurking. Just for a quick hello. If I can just feel where the aerial socket is, it's there. So we'll go back onto our 12 volt bench power supply. We're on channel 20. Let's put the mic in. Nearly put the duff one in, didn't I? And that's the other thing I need to try and sort out. Although we don't normally repair mics, we'll see if I can do something for him. See whether Mr. Chippie's there. Tango 21, Mr. Chippie.
Tango 21, go ahead.
Yeah, Roger, just checking it's working.
Yep, roger that, loud and clear.
Okay, Roger, 10-10.
10-10.
Good. Right, so that's the radio working. I've spoken to him all of 50 yards away. So that's it. Thanks for watching DNT B40. Radio's done. Just got to finish the power supply and sort the factory original mic out.